Hi, everybody. I want to take some time and talk to you all about the results of our lab observations that we made throughout today's lesson. So in the first activity, you watched some videos of fat being burned in what we refer to as an open system. In this picture, you see the fat is in the little container and the flame is burning. And you should have observed that with both the animal fat and the vegetable fat, as they burned, we saw a decrease in the mass. However, we were told in the previous lesson that the conservation of mass says that the amount of matter before and after a chemical reaction has to be the same. So that led us to wonder, why did the mass go down? From there, we decided to do the same test in what is called a closed system. This closed system was a vacuum-sealed container where we had the fat still in this cup with the flame going. And we looked at the mass before and during and after the flame went out. And what you should have seen is that the mass never changed. It was always 400.31 grams. At the end of this video, you were also supposed to notice anything along the sides of the container. Along the sides of the container, you might have noticed that there was some condensation or fog. What this tells us is that there was some water vapor, which is water in its gas form, that was hitting the sides of the container and condensing back into liquid, creating that condensation. Now, because the mass did not change, this proved that the law of conservation of mass is supported. We were able to capture any gases that were being released during the burning of the fat, and they were part of the mass before and after the measurement. And we saw that when those gases were included, the mass stayed the same. So the next question was, what gases are being released during burning? You may have noticed that in this system, the flame went out sooner than it did in the open system. One of the reasons for that could be that whatever is required for burning was used up because it didn't have free access to all the air in the room because of the closed system. So if one type of gas was used up, but the mass stayed the same, what other type of gas was created in this process? What we did next was we showed you pictures of a monitor or a detector that can tell us various levels of gases in a room. This number here in the middle is telling us how many parts per million of particles in the air are carbon dioxide. There's also a reading down here in this corner for relative humidity. What that tells us is how much water vapor, or water in its gas form, is also in the air. You were unable to read that number, but it started at about 30% relative humidity. The starting level of carbon dioxide before we closed the system and burnt the fat was about 769 parts out of every 1 million particles in the air. Near the end of burning, however, what we see on this reading is that it is now over 4,000 parts per million. This is reaching what we would consider very high levels of carbon dioxide. What this tells us then is that during burning, carbon dioxide levels are increasing. We also would have seen an increase in the relative humidity percentage if we could read this number. So we see humidity increasing, and again, humidity is telling us how much water vapor is in the air, and we also see carbon dioxide increasing. So what these two things are telling us is that when fat is burned and a chemical reaction is taking place, we see more CO2, carbon dioxide, and more H2O, water vapor. We also can clearly see that energy is being given off by this burning process. In this example, the energy is in the form of heat and light. When our bodies burn fat, they don't give off light, but we definitely get some heat from that reaction. Okay, so I hope this helps you put the various pieces of what you observed together, and hopefully you can come to some conclusions about what happens when fat burns.